Good day, everyone. So in preparation for our quarter examination, we will now proceed to our part 2 of our coverage, which is about solving rational equations with non-permissible values. So we have here an example, 3 over m squared minus m minus 3 over m minus 1 is equal to 1. And we need to find the values for m, or to solve the values for m. So to solve the equation, the first thing that you need to figure out first is what is the LCD. So based on the given, the denominators here are m squared minus m and m minus 1. In m squared minus m, so you need to apply your knowledge in factoring. So first is to figure out the GCF, which is m. And if you factor out the m, so what will be left is just m minus 1. And you cannot further factor it anymore. So we proceed to the second denominator, m minus 1. However, m minus 1 is already prime. You cannot factor that anymore. So that means you just have to copy it and align it with our common factor, our previous denominator. And bring that down. So you have m and m minus 1 in here. So the LCD here is m times the quantity of m minus 1. So the next step is to multiply the LCD in both sides of our equation. So on the left side, that would be m times the quantity of m minus 1. And the original left side of the equation should be enclosed in a parenthesis. And the right hand of the equation should be multiplied as well with the LCD m times the quantity of m minus 1 to maintain the equality of the equation. Then LCD should be multiplied in both terms in our left-hand side of the equation. So you start here. So what will be cancelled out here would be m squared minus 1 minus m. Because if you factor out m squared minus m, that's m times the quantity of m minus 1. So that means everything will be cancelled out in the denominator. And what will be left is just the 3 in the numerator. So similar to our previous reviewer, the common mistake of other students is they tend to forget to distribute the LCD on the second term of the left-hand side of the equation. So don't forget to distribute it here as well. So the m minus 1 will be cancelled out. So you have 3 and m. So 3 times m is 3m. And on the right-hand side of the equation, it is just 1. So this is application of identity. 1 multiplied to anything would just be the same. So that would be the LCD itself. Afterwards, we can simplify the right-hand side of the equation by distributing the m. So m times m is m squared. M times negative 1 is negative m. And then we make sure that so that we can further figure out the values of m, considering that the highest degree as of the moment is 2. So the technique here is to put everything on one side of the equation and make sure that the other side of the equation is a 0. So in my end, I would like to put everything on the right-hand side. So that means I have to add the additive inverse of the 3 and the additive inverse of the negative 3m, which is positive 3m. So to further apply the addition property of equality, you need to do the same thing on the right side of the equation by adding negative 3 and by adding as well a 3m. So what will happen here on the right hand side is 0, because you added the additive inverse of each terms, and then you bring down the m squared. Negative m added with the 3m, they have different signs. That means you need to subtract the absolute value of each terms. So 3m minus 2m is 2m. And then you copy the sign of the larger absolute value, the sign of the larger absolute value of each terms, which is the 3m, so that would mean it should be positive. Okay, now it's m squared plus 2m minus 3. You need to apply your knowledge in factoring to find the values of m. So if you factor this out, this would be m plus 3 minus 1. So you just have to double check. That's 3m. This is negative m. And if you add them, that would turn out to be 2m, the middle term of the trinomial. And then you just have to equate each factors of the right-hand side to 0. So that would be m plus 3 is equal to 0, m minus 1 is equal to 0. To isolate the m, you need to add negative 3 in both sides, applying APE, and then you will get negative 3 here for m. And on the other side, you add 1 in both sides to isolate the m, and 0 plus 1 will give you a 1. So as of the moment, we have two values, negative 3 and 1. Okay. But if you look at the given here is 3 over m squared minus m minus 3 over m minus 1 is equal to 1. So if you look at this part here, if the m is 1, so that would be 1 minus 1, which will turn out to be 0. So that means m minus 1 is a non-permissible value, because this will make the equation undefined. So it's either in the examination you will be asked what is the non-permissible value or what is the solution of the equation. So if the question is what is the solution of the equation, your answer would be negative 3. But if the question is what is the non-permissible value of the equation, kumbaga, if nagsasolve ka and then nakuha mo yung values na yun, pero hindi pala siya, it will not make the equation true. So that means that is the non-permissible value. So the solution set here contains negative 3 only. Okay, let's proceed to number 2. So the equation here is 3 over c plus 36 over c squared minus 4c is equal to c plus 5 all over c minus 4. Same process in number 1, we need to find first the LCD of all the denominators. So the denominators here are c squared minus 4c, and c minus 4. So if you find the LCD, of course c cannot be further factored, and then c squared minus 4c, you can still factor this by finding first the GCF, that's a c, and if you factor that out, you have remaining factor of c minus 4. Then make sure you align the common factors from the previous one. And finally, you have c minus 4. You can't further factor it anymore. So you just have to put that down below c minus 4. Then just bring that down. You have c, then c minus 4. So this is now the LCD, and you need to multiply the LCD in both sides of the equation. enclose the left-hand side of the equation with a parenthesis, and you have c times the quantity of c minus 4. Then on the right-hand side of the equation, you multiply it with the LCD as well. Then here, the left-hand side, you multiply the LCD in both terms. You distribute. If you multiply the LCD with 3 over c, the c will be cancelled out. And then you have 3 times the quantity of c minus 4. And then, if you multiply the LCD to 36 over c squared minus 4c, take note that c squared minus 4c, if you factor that out, that's c times the quantity of c minus 4, which is the LCD itself. So everything will be cancelled out, and what will be left is just 36. On the right-hand side of the equation, you multiply the LCD with c plus 5 all over c minus 4. So the c minus 4 here will be cancelled out, and you have c times the quantity of c plus 5. Before you isolate the c, you make sure that each side of the equation is written in simplest form. So you distribute the 3 to c and 4. You'll get 3c minus 12 plus 36. And on the right-hand side, you distribute the c as well to both terms of our binomial. So c times c is c squared, c times 5 is 5c. So on the left-hand side, we can still combine negative 12 and 36, which will give us a 24. Since the highest degree of the equation is a 2, we just have to make sure that the one side of the equation is a 0, and we put everything on the other side. So in this part, we will have to make the left-hand side of the equation a 0 by adding the additive inverse of 3c and 24. So you have to add a negative 3c and a negative 24. And to maintain the equality of the equation, you need to do the same thing on the right-hand side by adding a negative 3c and a negative 24. Since you're adding the additive inverse of the term, that will be a 0. You bring down the c squared and you combine 5c and 3c, that would be 2c and negative 24. So to find what is c, you need to factor the right-hand side of the equation. So if you factor this, that would be 24. That means if you multiply those two numbers, it should be negative 24. But if you add them, it should become a 2. 4 times. So the correct factor here is 4 times. 4 times negative 4 times 6. Because if you notice, negative 4 times 6 is negative 24. But if you add negative 4 and 6, that will give you a 2. So you just have to write it here, negative 4, and the other one is 6. Since we're able to factor the right-hand side and the other side is a 0, we can equate each of the factors with a 0. So c minus 4 is equal to 0, and the other one is c plus 6 is equal to 0. We need to add a 4 in both sides here to get what is c. We'll get a 4. Then add the negative 6 in both sides. You will get a negative 6. So if you check our given here, if c is 4, what will happen to the right-hand side? So this will become a 0 in the denominator. So that means the 4 here is our non-permissible value because this will make the equation undefined. If you, I will leave that as an exercise to you on how to double check whether -6 is really a solution to the equation, but it is. But I will leave that to you. But the 4 is obviously a non-permissible value because it will make the equation undefined. Considering that the right-hand side, it's c minus 4 in the denominator. So 4 minus 4 is 0. So the solution set here is just -6. So this is now the answer. For our third example, the rational equation is 2 over a minus 6 is equal to a over 2a minus 8. Always remember that the first thing that you need to do here is to find first the LCD of the denominators. The denominators are a minus 6 and 2a minus 8. To find the LCD, you need to find the factors of each expression first. For a minus 6, it's already prime, so you just have to copy a minus 6. But for 2a minus 8, the GCF is at 2. And if you factor out the 2, the remaining factor would be a minus 4. It's not the same as the factors of our previous denominator, so we do not align that. Bring down a minus 6, 2, and a minus 4. So that is now our LCD. And you need to multiply the LCD to both sides of the equation. Enclose the left-hand side, multiplied with a minus 6 times 2 times a minus 4. And on the right-hand side, you have to enclose it with parentheses as well. A minus 6 times 2 times a minus 4. On the left-hand side, you can cancel out a minus 6. So what will be left is just 2 times 2, which is 4. And don't forget, you still have the a minus 4. On the right-hand side of the equation, take note that 2a minus 8 is 2 times the quantity of a minus 4. So that means 2 times the quantity of a minus 4 will be cancelled out. What will be left is just a times the quantity of a minus 6. This time, we need to simplify each side of the equation. On the left-hand side of the equation, we need to distribute the 4 to a and 4. 4 times a is 4a. 4 times 4 is 16. On the right-hand side of the equation, we need to distribute the a and to 6. a times a is a squared. A times 6 is negative 6a. Since the highest degree of the equation is 2, the technique here is to isolate or to make sure that one side of the equation is 0. To do that, we need to add the additive inverse of 4a, which is negative 4a, and the additive inverse of negative 16, which is positive 16. Take note that whatever you do on one side of the equation, you need to do it as well on the other side of the equation. So you need to add a negative 4a here and a 16 here as well. Since you added the additive inverse of each terms here on the left-hand side, that will become 0. And you bring down a squared, negative 6a plus negative 4a is negative 10a, and this is 16. Since it is a squared minus 10a plus 16, you need to factor out a squared minus 10a plus 16 using the general quadratic trinomial, or GQT. If you factor that out, there should be two binomials. The first terms must be a. And take note, the second terms of each of our binomial if you multiply them, it should result to 16. And once you add it, it should result to a negative 10. So the correct factors that we're looking for here are negative 8 and negative 2. Negative 8 times negative 2 is positive 16, but once you add them, it will result to negative 10. So the second terms here are negative 8 and negative 2. Now we are now ready to equate each factors with 0. So it would be a minus 8 is equal to 0, and a minus 2 is equal to 0. To isolate the a, we need to add 8 and apply APE. It will result to 8. On the other one, we need to add a 2, applying APE, and it will result to a 2. Now, as of the moment, we have 8 and 2 as a solution. But if you will try to do checking, both numbers would make the equation true. That means there is no non-permissible value in our equation here. So I will leave that as an exercise to you. Automatically, the solution set here would be 2 and 8. So that's it for our part 2 of our review in preparation for our quarter exam. So I will be uploading the third reviewer or the last coverage of our quarter exam later. Thank you so much.